My name is Kat. I'm a backend engineer at Monzo Bank in the UK. I did a fair amount of Java at the start of my programming career. I did a tiny bit of Bash, a tiny little bit of Ruby, but predominantly I've been a PHP developer for about 7 or 8 years since I finished university. And that was before I switched to Go about 3 years ago. These days, it's actually my main and only language at work, because Monzo is built entirely in Go. We have about over 1,200 microservices, I think is the latest count, all written in Go. But I'm not here to tell you that Go is awesome, because this is a PHP conference, and after all, this wouldn't be fair. But what I'm hoping to do, and what I'm here for today, is to tell you how, not just how awesome Go is, but I'm hoping to convince you that it's worth learning more than one programming language. And I want to show you how this can change you as a programmer and make you a better programmer, based on my experience from switching from PHP to Go. Sorry. So you might be thinking, what the hell, Kat? Like, PHP solves all my problems. But does it really? Sometimes developers who only know one language will try to do everything in that language. And this can sometimes cause them unnecessary grief. There might be a better tool out there that would do a better job at solving the problem at hand, but you wouldn't know that if you only know one language. So just as you wouldn't use a screwdriver to hammer a nail into a wall, maybe you shouldn't try to use PHP for everything under the sun, for every type of problem that you might come across. PHP is kind of like the multi-tool. In fact, it's sometimes famously called the double-clawed hammer, where it sort of does most of the things okay, but maybe not quite. But that's okay. No language is ideal. But maybe it doesn't mean that you should necessarily stick to the good old hammer for everything. Sometimes it will do just fine. And it's a great language to start with if that's what you're most familiar with when facing a problem. But sometimes it can really limit what you can do. So learning another language is just like adding a new tool to your toolbox. The more tools you have, the more you can do and the more problems you can solve. And you can do things the right way. And it's a really great way to learn new concepts and great ideas for how to solve new kinds of problems that you might come across. And then you can even borrow concepts from one language to another. And maybe you can even improve the language based on something that you've seen somewhere else. And we've seen that with PHP. Many of the tools have been inspired by things found in other languages, like Composer. That was inspired by Bundler. PHP used to be procedural, and then Java popularized object orientation, and now object-oriented programming is pretty standard in PHP. So there is a lot of examples like this, and that's why learning a new language might give you some ideas for how to improve the work that you're doing. Let's have a look at Go. Sometimes it's called Golang, but that's just for Googleability. The official name is Go. It's gaining in popularity. It's actually been steadily growing in popularity in the last few years, but it's actually 10 years old, and its 10-year birthday was actually 2 days ago, 10th of November. It was released in 2009 as the sort of open source project. The Go 1 release was in March 2012, so that was 7 years ago. And we're now at Go 1.13, it's just been released. And Go 2.0 is also in the works, and the main thing that it's supposed to bring is generics. Go was written at Google by the 3 gentlemen here, you can see on the slide, Robert Griesmer, Rob Pike, and Ken Thompson. So pretty big names in computer science. Go is a compiled, statically typed language. That's the official definition. It's a bit like C, but with the nice things, like garbage collection and memory management. So you don't have to allocate memory yourself or worry about any of those things. And one of the main selling points of Go is the built-in concurrency, which we'll of course have a look at later. The biggest difference between PHP and Go are the mascots, and the derived mascots and the logos. So it's gophers versus elephants. They come in a lot of different shapes and sizes. This is a sample of the mascots that I have at home. The width of the gopher and the elephant is actually the same, but the gophers are about 20 to 25% taller. And I think the I size is the biggest differentiator. I'm only kidding. One of the biggest differences is how you run Go apps versus how you run PHP apps. PHP is an interpreted language, and so you need a web server with the PHP interpreted running on it, or you need the interpreted on your command line to translate your PHP code into machine code. And it does it on the fly, roughly speaking. Now we have things like opcache and so on. But roughly speaking, it just translates the lines of PHP code on the fly as you execute your program. Go, on the other hand, is a compiled language. And that means that you first need to compile the program for your chosen architecture, and then you can just run it like any other binary on your system. Why is this important? Because it affects the speed. Compiled languages are generally faster than interpreted language, just for the obvious reason that you do the work of translating the code into machine code beforehand, before you run your program. So you don't need to do this at runtime. So here we have some benchmark for a simple hello world application written in a bunch of languages. On the left-hand side, the leftmost column is Nginx serving a static file. So that's just for comparison. Nginx is written in pure C. So you can see that the two leftmost columns are compiled languages, C and Go. And that's not really surprising, that they are the fastest according to this. Node.js is impressively close to Go. Vanilla PHP, in this case, and this is a huge disclaimer, this is 5.6. That appears to be about 2.5 times slower in Go in this case, but this is also Go 1.4. So this is just some benchmarks that I found on the internet from like a couple of years ago. So this is PHP 5.46 and Go 1.4, and both languages got significantly faster since then. But the general idea, and what I'm trying to say here, is that's exactly my impression when I started with Go. It just felt so much faster. And I think that PHP was built for like development speed, not necessarily runtime speed. Go seems to be optimized for runtime speed, and that's sort of why it was chosen for it to be compiled. But that doesn't necessarily mean that it slows down your development process. Like Go compilation takes a second on average, so it's not like compiling Java. It doesn't take minutes. So let's have a look at some Go code. This is a twist on the classic Hello World program. So we have a string. Hello is a something you're looking for. And what we want to do is print out T or me at random in that sentence. So you can see where this is going. Terrible pun. The syntax is obviously different to PHP. The format is standard across all Go applications. So any Go code that you open up on GitHub is going to have the exact same coding standards, exact same formatting. So in Go, there is only one standard, and you just have to stick to it, whether you like it or not. There is a tool called Go Formatter, or Go Fimt, which automatically formats the code on the fly in the background as you write it, so you don't have to worry about it yourself. And honestly, you kind of get used to it very quickly. Whether you like this approach or not, it's obviously a personal thing, and some people got really upset because Go prefers tabs, and people, before they realize they can use soft spaces and they don't have to care about tabs, they throw out a tantrum. But either way, you just get used to it. There are ways around it. If you prefer spaces, just use soft spaces. The best thing about this is that you just don't waste time arguing about where does the bracket go on which line, or tabs versus spaces. Like, there's just none of this in the Go community, which is great. Like, imagine PSR2 and PSR12 just not being needed anymore, and everybody following the same standard. So in Go, you declare your package at the top. It's a little bit like namespaces in PHP or modules in Ruby, so sort of same idea. And then you have to declare what libraries from the standard package you want to use. So luckily, there is a tool that does this automatically for you on the fly as well, and it's called Go Imports, so you don't have to type this out by hand. And then we have our main function. Every Go program has to have a main function. And you might have noticed that there is no public or private in front of it, in front of the function declaration. And this is because Go has a very simple convention that names starting with the capital letter are visible outside of the package, and the names starting with lowercase letter are only visible inside the package, with the exception of main. Main is always lowercase. And obviously, if something is in the main package, then it's visible sort of globally. So this is true for variables, for function names, anything. So you won't see public or private in Go. And this is how we declare a variable. This is actually a long way of declaring a variable. Each variable in Go has to have a type, and you cannot type juggle. You can't change it on the fly. And there's also a shorter way of declaring variables, and Go will automatically work out the type of that variable based on the value that you give it. So here we create an array of 2 strings, me and t. And then say we want to print out that sentence 5 times with the random word each time. So we have our for loop, and notice that there are no brackets around the statement. So that's true for ifs and fors. There are no semicolons at the end of the lines as well. So there's a little bit less visual debt, which used to be a hot topic in PHP once upon a time. So let's run our program. We get 5 sentences as expected. And here we called Go run, which will basically take a file, compile it to the Go binary, and it will run it, but it will not actually create the binary. So this is just like putting your program in virtual memory. If we wanted to create a binary, we need to use a tool called Go build, and you run it in exactly the same way, and that will output a binary file. So in this case, this was compiled on Linux, and then you just run it like any other binary on Linux, and we get a similar result. So I mentioned using Go run and Go build and Go font and all of those things, and those are just some of the many, many, many tools that you get with Go pretty much out of the box. And when I think this is where Go wins over a lot of the languages. The super easy setup where you get everything you need to develop your app out of the box. It's just definitely a huge bonus. So in PHP, if you want to do unit testing, you have to install PHP unit. And if you want to debug or profile your app, you need to install xdebug and configure the extension. And then for PHP unit, you need to write that XML file. And it can get really tedious and boring, and it's a bit of a faff to have to do this for every single project and repeat it over and over again. So with Go, you get a formatter, a linter, you get your unit testing, performance testing, benchmarks. You get code coverage generation, you get documentation generation, you get different compilers for every architecture, and a whole bunch more just out of the box with the Go installation. And once you have it set up on your system, then that's it. You don't have to reset it up for every project. It's just available for every project from now on. So when I first started using Go and those tools, I was like, oh, this is going to save me a lot of time. Matt Trask would probably say, shit's legit. So let's talk briefly about how Go code is organized on disk, because that might have been confusing if you've already looked at Go and saw something called the Go path. So Go used to use a convention where all your Go code had to live under one root directory on your disk. You couldn't just put it anywhere you want, and it had to be within the Go path so that the Go runtime actually sees it. But the Go path is going away, so I'm not going to talk about it, just not to confuse you. And hopefully, if you're going to start out with Go, you're going to start out with modules right away. So modules used to be experimental in Go 1.11. Now they are fully enabled, and they are the default from Go 1.13. They've been properly battle tested by a bunch of really big open source projects written in Go, so they're pretty much ready to use for production. And modules are a lot like Composer, except for, if you can imagine, if you run the PHP command, and the PHP command will automatically detect and run Composer install if it sees that your project has a Composer JSON file. That's essentially what modules does. If there is a mod file in your Go project, it will pull down all the dependencies for you and then compile and run the program. So how many times have you deployed something to production and you forgot to run Composer install and your dependencies were out of whack? Like, I've certainly done this a lot of times. So this basically saves you that trouble. And the rest is similar. There is a sum check file, which is equivalent to the log file in modules. And then the rest is the same. Modules, sorry, I just forgot to click through this. So enabled by default now. And the last thing I wanted to mention is that modules require semver to actually work. So they rely on everyone using semantic versioning properly to work, essentially, because they will try and automatically upgrade your dependencies if it's safe to do so. So if it's just a bug fix, then it will try to upgrade it automatically. So on one hand, that's a little bit risky, but on the other hand, I think the idea was that over time, the whole community will get educated on using semver properly, and we won't have that problem anymore. And then this kind of came a little bit late into Go, and dependency management and proper package managers have been wanted for a long time. So there were a lot of open source projects that popped up in the meantime. I think GoDep is one of the most popular ones. So modules actually ship with the ability to, translate, 9, the sort of dependency files of 9 other package managers into modules so that we can convert the whole community pretty quickly onto using modules. So what kind of apps can we build with Go? I tend to think of Go as just a box of Legos that you're given. So you can build anything you want with it, like all sorts of cool things, but you kind of have to do all the thinking yourself. PHP, I think, is more like the ready-made tools, where some of the things have already been taken care of for you. There is a bunch more sugar in the library. But on the other hand, you're a little bit more limited as to what you can do, because you only can do certain things. Both languages, I think, are great for web apps or APIs. You can use PHP or Go to write command line apps, or even bash scripts. And I think PHP just excels at the web app level. Whereas with Go, you can build some low-level components too, like you can build a server, you can build a proxy or a reverse proxy, you can build a load balancer, like all sorts of things that basically don't require a UI and need to be fast. So let's move on to the reason why so many people start looking into Go, and that is concurrency. So as a PHP dev, you rarely, or in my case never, come across concurrency in PHP apps. You can use a PHP extension called pthreads, or there are frameworks like React PHP or AMP. I haven't tried any of them, so I don't know how good they are. But most PHP implementations that I've come across, they tend to be single-thread based. So I think it's just less common to come across concurrency as opposed to Go. Go has been designed with concurrency in mind from scratch, and it outright promotes it. In PHP, it kind of feels like it's been bolted onto it later. But I think it can work pretty well. I think it will probably be slower still than Go because you're using a framework, so just by that fact that you're using something on top of the native PHP, that's probably going to make it slightly slower. So it wasn't really until I started doing Go that I started to think about concurrency and what does it mean for my program to run concurrently? Like, how do I design concurrent apps in a safe way? And what does it mean for my app to run in parallel? And is concurrency the same thing as parallelism even? Turns out it's not. So concurrency is when at least 2 threads, in theory, can make progress in your application. And parallelism is when at least 2 threads are actually physically executing simultaneously. So this wasn't very obvious to me to start with, but it's a very subtle difference, but hopefully I'll be able to explain it more with a silly example. So this is stolen from a very good talk by Rob Pike called Concurrency Is Not Parallelism. And in this example, we just have a bunch of gophers running around and burning books. So one gopher is taking the books from the stack, the other gopher is loading them onto a trolley, the third gopher is taking them to the incinerator, and then the fourth gopher is taking back the empty trolley. So if you imagine every gopher to be like a separate thread of execution, in theory, in this example, we can have all 4 gophers running around and doing their job at the same time in an ideal world. So that means that this design is concurrent because in theory, all the threads can make progress at the same time. And you can scale this up however you want. You can add more of the same type of gophers to each group. You can basically just take those 4 gophers and multiply them. But the design is it still holds. It's still concurrent. But if only one of those gophers is running around at the same time and the rest is waiting, then the design is still concurrent, but it's not parallel. If at least 2 gophers are running around at the same time, it's also parallel because it means we're actually executing 2 threads at the same time. So we tend to talk about concurrency in Go because it's just a general form of parallelism. And it's worth keeping in mind that having a concurrent design doesn't always guarantee parallelism. And that very much depends on where you run your program. How many cores does your machine have? If your machine just has a single core, then it will most likely use virtual parallelism. So it will still use 1 thread, and it will pretend like it's running multiple threads at the same time. It will just cut them up and slice them in. So you use time slicing or something like this. But if you have multiple cores, if you have, say, 4 cores, you can actually have physically 4 threads executing each on a different core all at the same time. So it very much depends on where you run your code. One of the most appealing things about Go is how easy it makes to write concurrent programs. And basically, it all boils down to 3 words. keyword, the Go keyword, Goroutines, and channels. So a Goroutine is not exactly a separate process. It's certainly not a separate OS process. The Goroutines are mapped by the Go runtime onto OS processes. So the official definition is that it's just a lightweight thread of execution, which is all managed by the Go runtime, so you don't have to do it. And Goroutines all run in the same address space, so they can all access the shared memory, and that's where you have to be really careful. And you have to worry about synchronizing the access to that memory in some ways. So this is how we create a Goroutine. You just add a Go function, the Go keyword in front of it. And it's that simple. So now this function will magically be executed in a single separate thread of execution. So let's come back to a similar example with saying hello world. But let's say we want hello to be printed by the main thread and world to be printed out the same amount of times by a separate Goroutine. So we define a function called say, which takes in the word, and that will just print out the given word, say, 5 times. And then in the main function, we call the say function twice, but once with the Go keyword. So we call it once for hello normally, and then we call it with world with the Go keyword in front of it. So that means that the Go runtime will execute the second line in a separate Goroutine. And the important thing here is that this is non-blocking, which means that as soon as a line gets executed, the main thread will just move on to the next line or exit, and it will call say with hello. So the two calls will be, in theory, executed at the same time. And here is the output. So we get both words printed out in a random order by each of the Goroutines, and the order isn't really predictable. So if we run the program multiple times, we get a slightly different output every time. And that's because the two threads are running concurrently. And so without any deliberate synchronization put in place, the order will be completely random. If you notice those two columns and the end of them, in the third column, world was printed last, and world was being printed out by the Goroutine. So that means that the main thread, the main program, has terminated already while it didn't wait for the Goroutine to finish executing. And that's not ideal, because you can end up with zombie Goroutines in that way very easily. And they will just be running without any control over them, because you can't reach into them, because your main program has already exited. So to make sure that you don't exit accidentally until all the Goroutines are done, we can use something called a sync group. And so we can declare one for the Goroutine, and we add 1 to it because we're kicking off one Goroutine. In general, you just add 1 for every Goroutine you're planning to kick off. And then we kick off the function using the Go keyword. So this is also an example of using a closure. Go supports closures or anonymous functions. And in that closure, we use a special keyword called defer. Defer is a little bit like finally in PHP, except for you can put it anywhere you want in your code. Defer is always guaranteed to be executed when the function ends. So after everything in the function runs, it will execute all the defers in the orders that you've defined them in your function. So the first thing we do is in that defer, we call done on the wait group. And that essentially tells the wait group, I'm done, subtract 1 from your counter. And then we just call say world as normal. And then in the main thread, we call waitGroup.wait, which basically means that until the wait group's counter is back to 0, the main thread will just wait on this line until that happens. So you wait for the Goroutine to finish. This sort of thing is really useful for things like making sure that you always close your file handles, like leftover file handles, because you can just open a file and immediately put a defer in there saying close the file handle. And that basically means you don't forget to do those things. Or you call the wait group, the done on the wait group, as soon as you're branching into a Goroutine. So that silly example shows you that analyzing concurrent programs can start to be really, really tricky for a lot more complicated cases. And that's because some things might deliberately happen at random when you don't care about the order, and some things have to be carefully synchronized, or we have to make sure that something finishes before something else starts. And there are a whole lot of other things, other constructs in Go, like mutexes, for synchronizing access to memory, so you don't accidentally have 2 Goroutines or more overriding each other's memory. But luckily, a lot of the native Go functionality, it's safe for concurrent use, and the Go creators have put a lot of safety nets in place and a lot of sugar to make sure that you can easily manage all those problems. So it's not as scary or as complicated as it sounds. And the Go toolchain actually has a race detector built into it, so you can also run your program through that, and that will help you debug any issues or spot any issues. An even better way to provide synchronization in Go programs is to use something called channels. And you can essentially think of channels as pipes that you can put values in on one end and you can take them out on the other end. So if you share this queue or this channel between two different Go routines, you can send and receive messages between them. So channels are in Go are first-class citizens, so they're equivalent to variables. They are typed. So each channel has to have a type declared. So you cannot put values of a different type into a channel. Channels can also be bidirectional, so you can send or receive, or they can be defined as one directional, so you can only send or only receive from a given channel. And by default, the sending or receiving something from a channel is a blocking operation, and that is the key, because the program will wait on that line that is waiting to receive something or put something on the channel until that becomes possible. And this basically means that it allows us to synchronize using Go routines without using any explicit locks or mutexes or any of that ugly stuff. So in Go, there is a saying that you shouldn't communicate by sharing memory, so sharing locks or sharing mutexes. You should share the memory by communicating, and the communicating is values across channels. So we can declare channels in Go just like any other variables. So here we declare a channel called messenger, which is of type string. So you'll have string values passed on to it. And this is just a declaration. In order to use it, I need to actually create it. So that happens on the second line, and there is a special keyword called make to make that happen. And then to send the value of the channel, there you use a second special operator called the arrow. It's just the arrow. And the arrow usually points in the direction of the data flow. So if you want to put a string called oh hi on the channel, you just put it on the right side of the variable. And then if you want to receive the value from the channel and maybe assign it to a variable called message, you do the opposite. You point the arrow away from the channel into wherever you want to receive it. So this is how you might implement a typical pattern which is used in concurrent programs a lot, called the worker pool. And the worker pool is essentially a pattern where instead of having just one channel, take some values in, process them, and then wait for the first value to be processed until you can pick up the next bit of work. In a worker pool pattern, you have a bunch of threads picking up work at the same time and processing them independently. So you basically speed it up by a factor of essentially how many extra threads you have. So in this case, at the top, we create a channel of jobs, and again, we use the make keyword, and the channel is going to accept something of type task. Task is a struct. It's not declared here, but it doesn't matter what it is. It's just a struct that defines a task. And then at the bottom, we use a special for range construct to essentially loop over an array or a channel or something that defines the items of work to be processed. So work slice in this case is a slice. It could be an array. It could be a different channel that receives values. So whatever it is, the range operator essentially just iterates over that, and then it puts each task onto the jobs channel. So it essentially loads up the channel with the tasks to be processed. And then in the middle, we have a for loop, which for a certain, so let's say we define the number of workers in the pool that we want to have as limit. So limit could be any number, 5 or something. And for each, we sort of incrementally spin up a Go routine until we hit the limit. So we kick off a Go routine with the Go keyword and count it as one thread. And then in that closure, we also use the for range construct to range over the jobs channel and pick up tasks from it and then do something with it. The important thing to note here is that all those Go routines, they all range over the same jobs channel. So in theory, any one of those 5, let's say, Go routines can pick up any task. You don't know which Go routine is going to pick up which task, but it doesn't really matter here. As long as the tasks can all be processed independently and they don't rely on each other, that's completely fine. And then they will keep looping in that inner for loop until the jobs channel is closed. So the moment the jobs, something else, like the main routine, will close the job channel, then they will all terminate the for loop, they will all exit, and all is well and good. So hopefully you can see that concurrent designs like this can really speed things up. And for me, just the ease of picking it up and go and looking more into concurrent designs and even event-driven designs, because channels can be used easily for passing events around, it was one of the reasons why I really enjoyed learning Go so much and why I got hooked. You can obviously try the frameworks in PHP with this, but I think using a language that just outright promotes concurrency and using it in a safe way, it just makes it so much easier to pick up. And we actually had a real-life example of a case like this at work, at my previous job, where I was tasked with rewriting an old legacy PHP application. It was just a procedural script that was parsing incoming emails. And so you would pick up an email from the server, it will process it, and then pick up the next one. And so at some point, once we started getting a lot more emails than we used to when we wrote this originally, it was running with something like 5,000 emails in the backlog to be processed constantly, to the point where it was just grinding to a halt. But then we realized that actually every email that is incoming, it's independent. It can be processed independently. So why are we waiting to finish processing one before we start processing the next one? Can we just process 5 at the same time, or however many we want? So we rewrote this in Go, and the number of workers was actually variable, so we could just flick it on the fly to be like 10 workers, 20 workers, or 5 workers. And sure enough, the backlog was cleared, and that Go application never ran with the backlog. It was just all so much faster at processing the emails. So that really helped us, and it was just that simple change of design. So my intention wasn't really to tell you that Go is better than PHP or that PHP is better than Go. They're just different, and you should think about what you want to achieve and what you want to build first before picking the language to do it in. And you should think about which language will help me solve the problem in the most efficient way, in the quickest way, in the most elegant way, in the most understandable way, even. And generally, I think in this day and age, we need to all be getting smarter as programmers. And we need to find ways to optimize the processing of whatever it is that we're doing with the increased loads on our systems, given that our hardware is no longer giving us the free benefit of 50% more efficiency every 18 months. So Moore's law doesn't really apply anymore. It's more like 22% per year now. So we can't just really be lazy and count on the hardware developers to just do our jobs for us. We need to start getting smarter. So I think exploring other languages just gives you that benefit of discovering all the new different patterns, like event-driven design or concurrent processing in general, to just help you speed things up. I genuinely think that as we're reaching the limits of the hardware and the language optimizations, the focus will shift to making our programs concurrent. And you kind of see signs of that popping up on Twitter for PHP. So we're already thinking about running our tests in parallel. So it's exactly that. It's that shift in thinking from doing things sequentially by default to doing things in parallel by default that I think it's really important to make that shift. And then there is something called the production-grade async programming framework for PHP, quite a mouthful. It's called SWOOL. And that just feels like writing Go in PHP. I kid you not. It has exactly the same thing. It has channels, it has coroutines, not Goroutines, and it has exactly the same concepts. And you can try it out today. And then we're also looking at things like JIT and for PHP 8. So that's just trying to make more of PHP compiled, because that's what would make it faster. So obviously, I ended up comparing the two languages quite a lot as I was going along. So here are some of my favorites about each. I still think that PHP is just great at getting things done quickly. Like if I need to bash something out quickly, I'll probably do it in PHP. Maybe less so today, but certainly true a year or two ago. And I think I like that PHP is a mature language. It's way older than PHP. It has a lot of mature frameworks and libraries that are really well established. There are certain things that are really well established, like if you want a dependency manager, obviously use Composer. I love that there are a lot of docs and tutorials online for PHP, although Go is very, very quickly catching up. I like, the community is older, it's 20 plus years old. And I think that PHP 7 was really a huge leap forward in terms of speed and efficiency, and just to bring PHP back to the game. And I love the ability now to enforce types in PHP. It's one of my favorite changes that's happening. But there are also quite a few things that I liked about Go as well. I love the strong types. I was never a fan of type juggling. I love the sort of idiomatic Go ways of doing things, and that's just the approach popularized by the Go authors themselves. And that's about keeping things simple, stupid, like don't overcomplicate if you don't need to. This is why the standard library in Go is pretty simple and pretty limited, and it was deliberately not extended over the years, just to keep it simple. I love the Go error checking policy, so I'll mention that in a minute. I love that Go has multiple return values. So this is where you can return 2 values, or however many values you want from the same function. And I feel like this is more natural because your function can return a value or an error. So why wouldn't you just put that out there in the code? Like, I didn't like in PHP how the error is always a surprise. Like, you can just get an exception and you have to try and catch the whole thing, hoping that you will catch the right thing. In Go, it's very explicit. If your function will return an error, it's just out there. You know it might return an error. I love the concurrency. I love the built-in tooling. I love that it's just so easy to run and install on your system. I like the wide range of applications. Go has a built-in web server, so you can like spin up a web server in your Go routine, in your Go program with 1 line of code, but you can also do all the infrastructure components. And I just love how fast it is. It feels so much faster than PHP. So this talk wouldn't be complete without briefly mentioning the communities for both languages. They differ in many ways, but I think they're equally great. And this talk is kind of proof that you don't need to limit yourself just to one. The PHP community, I think it rocks. It has so many great conferences and meetups. So here I think it's James and Jeremy at Bulgaria PHP a few years ago. But Go is quickly catching up. Gopher cons, as the Go conferences are called, they are now all over the place. There's one in China, Brazil, there's a bunch in America, a bunch in Europe. If you've ever been to PHP UK, the creators of PHP UK started a Go conference about 4 or 5 years ago called Golang UK, both happening in London. There are also lots of meetups for both languages. I now co-organize the London Gophers meetup. Until recently, I was also organizing or co-organizing a PHP Southwest meetup. So even just that, the experience of running a PHP meetup then just helped me bring a lot of useful things and tips and tricks to the Go meetup. So you can sort of apply cross-community tips. Some of my not-so-favorite things about each, or what I think could be better about each, because no language is perfect. I think PHP, as opposed to Go, feels a bit more inconsistent, and that's just like the baggage of time with the naming inconsistencies, but Go is generally feeling more consistent. PHP, I think it just kind of allows you to do stupid things sometimes and get away with it, which is really dangerous, especially for new programmers who just might not know any better. I think that it's a lot more verbose these days after writing so much Go, like just having to type in public and private. I now always forget this in PHP. And I really wish for multiple return values in PHP. I think that would be, like, I'm a strong fan of that. Go, I think, again, due to the age difference, it feels like a slightly less mature ecosystem. Up until very recently, we didn't have a dependency manager in place, like a proper one or an official one. And then sometimes I catch myself thinking, oh, do I really need to do it from scratch? Because Go just doesn't have as much syntactic sugar as the PHP libraries. So sometimes I think, oh, in PHP I could just call this function to do this on the string, and in Go you sometimes have to write it all yourself because there's not as much sugar. So an interesting observation for me, though, is have I started doing things differently in PHP now that I've been doing Go for some time? And the answer is yes. And I think the most important thing is that I'm now much more mindful of keeping things simple and clean, even though the PHP language doesn't really force me to. And I also became way more strict with types, just out of habit. And that was even before we had the strict types introduced in PHP. So I never liked type juggling, as I said, so now I always make it explicit in my PHP 7 apps. And I'm also looking forward to the type properties, class properties in 7.4. I now tend to use shorter and more sensible names. So if I have a class that sits in the namespace controllers, do I need to really call it the home page controller? It's kind of obvious if it's in that namespace. I certainly avoid enterprise naming these days, like public static listenable future chain of listenable future and a function which extends blah, 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 dear God, make it stop. This is like my favorite example of the enterprise naming that I now avoid like a plague, and Go really, really promotes that. Error handling. So imagine we're validating a name. So the two codes on the left and on the right, they do exactly the same thing. I used to write a code that looks a lot like the code on the left. And right now, if I look at it, like if I start reading through it, I can't even easily tell you what it does because I have to stop and think for a second. Whereas the code on the right, like if the name is empty, you return false. If it's not a string, you return false. Otherwise, you return true. Well, it's a name validator, right? So the difference here is in the thinking and that you handle the error cases first before you do the proper thing. And that's something that I definitely picked up from Go. It's not a new groundbreaking theory. It's just all object calisthenics. But I think Go is really good at enforcing that. And it was actually from Go that I picked it up more. So the benefit is that you just don't run the risk of doing something accidentally when there are errors that already happened. So rather than checking for errors at the end, you just do it up front, and then you don't have to worry that you've missed a case somewhere. And it also gives you the benefit of having only 2 lines of sight. And this is like a definition from the object calisthenics. Instead of having to sort of go 3 levels deep and then process everything in your head, it just makes it more understandable if you only have 1 level of indentation to pay attention to. So it makes your code easier to read. It makes it easier to spot any issues or any cases that you might have missed. So if you've never heard of object calisthenics, I really highly encourage you to Google that. There's lots of information online about them. Interfaces. So using interfaces in Go is fun because they're implicit. So for me, if you design Go really encouraged me to start thinking about how I use interfaces and where I put them in my code. And I think that if you design your domain well, if you leverage the power of interfaces in your code, if you do proper interface segregation, your code is so much easier it's so much safer to change and modify. So this is actually how I really got into DDD and hex architecture, and that's basically through the super easy use of interfaces in Go. So it's slightly different than in inheritance-based languages. It's just a slight difference in thinking. Because in inheritance-based languages, we think that if something is an instance of interface X, it will have those properties. In Go, the focus tends to be the other way around. So if something implements functions A, B, and C, then it is of type X. So it satisfies the interface. And you don't actually declare that explicitly in Go. The Go runtime will work it out by itself if your struct is implementing a given interface. So here, if we define a shape interface in Go with an area function, then we have a circle struct which implements an area function of some kind, so just calculates the area for a circle, then Go will know that the circle struct implements the shape interface because it implements the area function. And you don't need to declare that anywhere. So you can easily refactor your code. And as long as it still compiles at the end of it, like if you suddenly change the underlying struct, as long as you still provide the same function with the same name, it will all compile and it will all work. So it's slightly less work when you're refactoring because you don't have to manually verify all the references. In PHP, we have to explicitly declare that something implements a shape interface. So I think that learning Go has made me a better programmer, for sure. I think that knowing more than one programming language basically gives you more than one worldview on things and on problems, and you can share ideas across languages. It goes without saying that it makes you more employable. These days and age, many companies are looking for polyglots. And it just feels great to have another tool under your belt, especially if you've been using the same language for so many years. Maybe you're bored a little bit. So I really encourage you today to go and learn whatever language you wanted to look into next. It doesn't have to be Go. If you wanted to try out Go, then here are some links and some recommendations from me on where to start. So the Golang.org website, it really has it all. It's a really good starting point. There is a blog where the Go creators kind of explain some of the aspects more in depth. There is something called the Tour of Go, which is just basically a walkthrough tutorial for getting started. There is something called the Go Playground, which I think is really awesome. It basically lets you run Go code in the browser. And the Playground is even incorporated into the Go docs, so that if you look up something in the Go docs, you can actually try out the function and tweak it and try different input cases, for example, on the docs page. So that would be really awesome to have, for example, in PHP. Because how many times you see a function and you have to write a simple snippet to actually try it out. So with the Playground, you can basically do it in the browser online. And I also put some links to some of my favorite talks from Go. Concurrency Is Not Parallelism is the 20-minute talk from Rob Pike that I mentioned already. Simplicity is Complicated is another really good talk from Rob, and that basically talks about how hard is it to actually keep your code simple. Building Containers in Go is a talk from Liz Rice, and if you're into Docker, she basically builds a very simplified version of Docker in Go in 20 minutes on stage live, and it's awesome. Then she did another talk, which is Debuggers from Scratch, where she writes a debugger in Go in 20 minutes on stage. So if you wanted to find out more about how containers or debuggers work in principle, then that's a good way to find out. I've already tweeted the link to the slides, so you can check out the links afterwards. You can hit me up on Twitter if you have any questions or comments. Please give me feedback on Joined In. I'll really appreciate it. And with that, thank you so much for listening.
Right, so we're a bit over time, but let's try to do some questions. We spoke about this one when we were inside, so if you were in a Golang conference, what language would you suggest?
Very troll question. I wouldn't suggest Java or PHP because a lot of the Go programmers come from those two languages, so they probably already know those two. I'd say Rust, because Rust seems to be the Go on steroids. So probably that.
Then, well, you briefly mentioned that, but scenarios where you would still use PHP and Go and like?
I think simple websites, like any dynamic web applications, I probably use PHP as just like the front-end layer and then have some API underneath it. I wouldn't maybe necessarily use Go, although Go has a really good templating system these days, so it's catching up. But yeah.
Then Go excels at building microservices, but would you still use it for a large code base, like trying to build a structure monolith or something like that?
Probably still Go. I don't have much experience with large monoliths in Go. I have a lot of bad experience with large monoliths in PHP. So
well, yeah, but I guess that relates to any language, I guess. But yeah, fair enough. And yeah, someone is asking about, well, many people liked it. Why did you migrate to Go instead of like trying to, optimize PHP, move to PHP 7, do some benchmarks, if you did? I don't know.
So that was at a time when PHP 7, I think, just came out. So this was a few years ago, like three or 4 years ago. So 7 wasn't really an option, and actually in my company, it just wasn't an option because it wasn't really incorporated into the build pipelines and all of that. And we tried optimizing PHP. It was actually already a very crude procedural, like raw PHP. So there weren't any classes declared. There wasn't a lot of linking to do or anything. So the code was pretty simple already, and it was just about the design. And you can't really improve design with just changing the language.
Mm-hmm. And then there's that I thought this would be coming. So there was this tweet about the 1,500 microservices. Yeah. So they're asking like, if you think this happened because of the Gophers in your team embracing all this architecture versus people, proficient in other languages, like if you influence that or like.
Yeah, I think it partially happened because of that. I think a lot of the original Monzo team had seen a similar architecture built at the previous company, so they just saw it work somewhere else, and they basically just replicated that original idea. And I think it was just the sort of wanting the strict types, but also wanting a quick compile time. So that's why Java was ruled out. I know like starting runs on Java, so that's a different way of building your bank. But we just basically wanted speed, very quick compilation time. We wanted homogeneous services, so like we wanted code generation to be available to like build the same thing over and over again. And the strict types, I think that was the main idea.
And if there are any extra questions, because we're really running out of time. Okay, if not, thank you, Kat.
Thank you.